Okay, let's give a round of applause to Michelle Leroux here on the stage. She is CIO for Solines.net, and she's going to be talking about message-based microservices architectures. I'm personally really excited to hear about one thing in that talk because I have no idea what this means, which is poison messages. Yeah. We are going to run for the whole 40 minutes for this talk. There's going to be no normal Q&A session, but since there's nothing in this room after that for quite a while, you can all stay and talk with Michelle after the talk.
Okay.
So another round of applause, and we're going to start.
Okay. So, my name is Michelle Leroux Bustamante, and you already know that. I have a company called Solines. We do a lot of different things, but I run the microservices security practice. I'm going to share with you an extended sort of list of things that we do on a regular basis with our message-based microservices architectures. Not that every microservice architecture uses that model, but that we frequently run into it on different platforms. So, there's a lot to cover. Brace yourself. Let's go. Typical Michelle talk. Let's start with microservices and the scope of it, right? It's an investment. It's not something you do just because you can. It's going to take time. It's going to take resources. It's going to cost money, depending on the scale, of course, right? So what that means is we have to invest in the business motivators. And the way we usually do that is we would go through like a discovery phase, right? Where we sit down and look at, what is the business problem? What are they trying to solve? When will we potentially get the ROI? Maybe build a bit of a strategy roadmap. Is it a 2-year project, a 4-year project? At the end of the day, the most important thing is that the business sees the value. If they don't, then after they spend some money and they don't see anything coming back quickly because maybe you haven't crossed the chasm, they will possibly pull the project, right? So very important you get the business behind it. And then we don't just start throwing microservices into the cloud. We're probably going to take some time to design. And as we do that, we're going to think about our domains and our subdomains and our entities and aggregates and, kind of try to get a rough estimate of all those things, right? And then we'll start looking at maybe some POC work, right? How do we maybe get familiar with the tech stack we might be thinking of, some of the dev practices, some of the DevOps practices, and so on. And get that out of the way while we deep dive in each of the domains and think about design. And then, of course, we can go to the next phase, which is, are we going to start coding up the whole microservice solution? Or are we going to maybe, if we are migrating, because it's even harder, right? When you're greenfield, you can just start and think about your domains. When you're migrating from an existing big ball of mud monolith, we've got other things to deal with, like keeping the existing system running while we add on maybe some net new features that give business value early. So usually we take it slow, right? When we have a lot of things to do there, we'll do some proof of technology. I know you wondered what that acronym meant. And after we do the proof of technologies, then we're ready to do full-on development, right? So it could be 1 quarter, it could be 3 quarters. At the end of that, we're going to start, accelerating because we're going to have practiced our DevOps practices. We're going to have visibility and logging and monitoring baked. We're going to have automation, all these good things in place from a little slow process, but it's in production. And we've done DR, right, disaster recovery, and we practiced all those things with just a couple of services that hopefully gave some business value. And then at the end of all of that, we hope to see the ROI, right? So the ROI is where the business people get happy, and that's when they do their happy dance, and everybody says, let's keep going, right? Okay. So domain design, very quick intro before we get into the messages. We're going to think about different domains in our system. I don't know what yours are. Everybody's got different domains. Probably we all have something in the way of identity, authorization, maybe accounts or something. And we're going to break that down into possibly 1 or more microservices within the domain. Some of them have 80. Good, right? But that means I might have subdomains. There's some categories, right? Once we break that down, after our microservices are defined and the categories of those and the aggregates, we're going to probably have a data backend for each, right? So that's the vision, is that we're going to have every microservice own their own data, and that is where we get into some other dilemmas, right? So when we think about domains, we think about big, views of the aggregates. When we think about our microservices inside, we're thinking about data modeling, right? And we're thinking about how we break that up. And when we get into one of the domains, let's take identity as an example. So identity server is, a UI that does log in and log out and request tokens so that applications can get tokens and call APIs. And it's got a backend, right, for configuration for users. So each of those could be microservices. And then at the end of that, we're going to have maybe some UIs that talk to those services, right? One for config, one for user management, one for self-service, log in, register myself, confirm my password, etc. And then when we get to the next phase, we might think, well, have we gone granular enough, right? Like, is it really 2 microservices, or do we want to get to this point where maybe those microservices each own their own backend? And why would I do that? So this one is less obvious, right? Users are users. Why would I break that up? But it's not if you think about scale. 2 million users, 20 million users. We want high throughput on the read store, right? We want login to be fast, stable, uninterrupted. And we want it isolated. Microservice deploys as a unit. And we don't want to update identity when we're updating user management or self-service, which helps reduce support calls. So that's a business driver. There we go. Now I have a reason to break it up. So things like that will come up. Those are decisions you'll make. And then this would be 4 microservices now in the domain. So why would we add messaging to that is the next question, right? So when we think about messaging, we think about the distributed data problem, right? Where we have all these different microservices. They each own their own backend data aggregate. And as a result, right, we have to figure out, well, when I update this one, what if some of that data should get over here too? And this is not a new problem. We've dealt with it in the past with SOA. We've dealt with it, in different ways, right? 2PC and other mechanisms. But eventual consistency in messaging has become much more common today because our backbones in the cloud especially are much more reliable than they used to be. We can count on the platform. We can trust the platform. Guaranteed messaging, right? And there's just new tools that help us to embrace that. So I'll focus on that as a way to solve that problem and a way to build a microservice architecture with some other benefits. So thinking about eventual consistency, how would that work? Same architecture, right? I have a number of microservices with some data behind. And I'm going to have messages, or maybe let's just think about the things that happen when I register as a user. I'm going to go to my front end for entering my email. I'm going to register. I'm going to get an email and click the link. It's going to confirm me. I'm going to set my password at that time. It's going to activate my account and maybe send a message saying a user was created in the system so that somebody could listen to that. So this is just a list of activities that need to happen. And when those activities happen, we need to eventually make it so that the user management side knows there's a new registered user, unconfirmed or not. And we need to make sure you can log in by updating the identity side so that you can actually log in. And the way we might get that done with messages would be, maybe put a layer in here, right, where the writes are sending messages to topics. You might have a topic per domain, and that preserves order within the domain. And then we would, from there, break up, which messages matter to each of the microservices within the domain. So there's some thinking to do there. Once we have those messages going to topics, we have consumers, subscribers, projectors, all interchangeable terms that will project data or do something with the message, right? So the idea here being, I now have these verticals, right, where each of these microservices kind of own their own message, right? And only this microservice ever sends this one or that one or that one. So you have a really nice boundary of fits in your head microservice design, right? You don't have to think about 500 messages at once. You think about just these and just these. And this is the activities that happen within these specific microservices. Makes it a little bit manageable because we need to look for those opportunities, right? And then continuing with the thought of eventual consistency, right? What does that mean to the system now? So when I send that user registered, what's going to happen is I can listen to that message at the other microservice within the domain. And I can care about it and update both of those stores. And likewise, when the user confirms their email, right? And when they do password set, and when they're activated, Now we finally have a user at the identity side. So this is something that sometimes is called CQRS views, but essentially we're talking about domain messages that we can listen in on, subscribe to within my domain, and in some cases outside, because you might have auditors or something that pull in from many domains. And there's some techniques that we could dive into there, but we'll just keep going. So another benefit we get out of all of this is potentially the ability to build new projected aggregates or history logs or audit or something, right, from those messages that we've collected. So if we save the messages, then we have that opportunity. And I think that's a really important point for business value. One of the number one problems, right, auditing, businesses need to maintain history of what happened and when was your password changed, who elevated your permissions. That goes across many domains, right? They need a history, they need an audit. Who wants to build a history table? Nobody put your hand up, I know you don't. So, you know, let's focus on other ways we could achieve that. Messages is one way. And that means we can capture the messages. It also means we can now complete the design for our microservices without worrying up front about whether or not there's dependencies between the data behind, okay? So if we can get past that problem and just trust that it's okay if this evolves a little, have a decent enough design to go live with those first proof of technology stack. And as you grow, you'll learn, you'll find patterns, and then, you know, change might be okay, but you'll always have your messages, right? Okay. So we have to do this with code, right? So we need a technology stack. How do we build this stuff? And so in the middle, typically we would have a container platform, and the container platform is going to have my web apps, my APIs, right? And maybe my consumers and subscribers and projectors, right? And that gives me full visibility in a cluster of all those things that are running, and just see that they're all healthy and happy. And the way they fan out will be different, right? Because an API and a web app are going to have an endpoint always alive and scale out as needed. And, you know, consumers, producers, or consumers, projectors, all of those, same thing. They're going to need to potentially be listening on partitions. And so I might need to scale them or I might not. That's another data point, right? And those are all details you'd figure out, but of course, that's what container clusters give us, right? The ability to scale each of those independently according to what makes sense. And of course, those will deploy then to the container cluster. And then on the back end, I'm going to have some sort of data backend. I'm going to have relational and or document databases. Doc databases are a great backend for microservices because they're flexible when you change your data model. But of course, that doesn't mean versioning doesn't matter, right? We're going to have a cache probably. We're going to have a messaging backbone. We're going to have logging so that we have diagnostics, visibility into the whole health of the system. So these are things we care about. And some of those might be part of the cloud architecture. So if you're in Amazon or Azure, then you might use some of the features provided for you in that infrastructure, in that environment, so that you don't have to manage everything. But of course, some of these things, sometimes folks will just run them all in Docker. And especially when we're testing locally, we can achieve that. So the beauty is, I could give developers, and we do this on a regular basis, an ability to do git pull, compose up, or kube deploy, right, locally with Docker Desktop, and have them functional with seeded data and all the backends running, all the apps that you want to test running. And when you're only working on one app and not the other, then that's the one you go into code for, right? And so this is a nice way to get that done. So let's talk about that, right? So usually I'll go ahead and I'll create some sort of harness for testing these things. And so if we kind of come over here, and I'm going to go select one of my windows that have reordered a little bit. Okay. So I have this test harness, right? And what this test harness is going to do is it's going to be able to show me, you know, I'm going to let it test messages for the user login process, right? So coming back to what I have here, I have a bunch of command lines here. I have a web app that needs to be running, so I'm going to do a .NET run of that. And over here, I'm going to want to run RabbitMQ. So I'm going to do a start of my RabbitMQ backend. So I'm going to test this one with RabbitMQ because I'm going to simulate this, and Service Bus would be the cloud version. So, you know, I might pair a queue versus a streaming type locally with the similar in the cloud. And then if I'm doing Kafka locally, which I'll show in the second demo, then in the cloud that might be like Event Hub or Kinesis. So you're thinking about the technologies that you're using when you're doing this. So now I have RabbitMQ up and running, right? And I have my web app up and running. And I can go ahead and start my runtime consumer, which is going to pull the messages and presumably write to a database, right? So we'll do a .NET run on that. And then lastly, I might have a history consumer. But I can bring that up secondary, and let's go ahead and hit back to here. So if we go to RabbitMQ, you're going to see I've got two queues, basically, right, that have been created, one for history, one for runtime. And I can go over to the exchanges. You can see the topic. And if I kind of keep it here and start sending some messages, right, things will happen. So I can go ahead and hit home. And I can create a new user. So let's do Michelle Busta plus cloud, DockerCon live 1 at gmail.com. And I'm going to go ahead and copy that. And then I'm going to tab in here and do a password. And then I'm going to do an email. And I guess that's probably good enough. And then I'm going to just pretend and get some things done. Log in, log out. Maybe I have 4 login failures, or 5. Maybe I lock my account. Maybe I get unlocked. So a bunch of stuff just happened, right? And I can pop down here, and I can see that those things are coming through, right? So I'm picking up those messages from the queue. And in the meantime, history actually hasn't picked them up yet, but will if I go ahead and run it, right? So as long as the messages are still preserved, I can go back and project that new view later, right? So this is a good thing. So there you go. Now, that is just a quick way to do local testing. That exact example has, Service Bus, Kafka, and then I can flip the config and test against cloud. Locally, RabbitMQ, Kafka, and then in the cloud it would be Service Bus or Event Hub, right? So it's a way to test your technologies out. Each of them have similarities, and then there's some differences in the way they behave in terms of partitioning, in terms of how you need to scale them for partitions, in terms of how the messages are kept and stored, and in terms of how poison messaging might be dealt with. So there are choices to be made around which technology feels right for you based on that, but all of them can scale. And it's really just a matter of sometimes preference, okay? So coming back to ideas, this is a much bigger example, right? Which would be, hey, now I've done my harness, I've run my backend in Docker and locally, and I've tested out my stuff, and now I'm gonna build the real app. I can run the backend, which are all the red things in Docker. I can build my app in Visual Studio if it's an ASP.NET Core app, in this case it is, and I can give it a run. And then when I'm ready to test end to end, I run all the things in Docker and I debug with my logs, because we all know that's a good thing to do. And that helps you make your logs better, right? It makes you a better person. So what we're gonna do here, right, is do a ls here, and we're going to do a start demo.backend Mac. So this is going to start my backend. It might already be started or something, but yeah, I might have left them running. So this has my elk for messaging, for logs. It's got my Kafka. It's got my Redis because I'm caching in the identity solution. It's got a tool for pgadmin so I can read the database. I'm using Postgres locally for SQL type, and I've got Martin installed for doc database. You can switch those around. You can use Mongo, Couchbase, whatever, right? So these are just choices. And so with that running on the back end, let's go ahead and run the front end. So let's do a start apps Mac. Okay, and so this is just making sure all those guys are running, so you can see all the containers are up and running. I've got a web app for registering a user at 5007, and what that's going to do is give me the dance of creating a user, registering, confirming my email, logging in identity, coming back, calling APIs, consumers are running, creating user backend, and history and all of it. Okay, so as a point of reference, what this is just illustrating is, look, when you're doing a messaging system, you want to be living and breathing that even on your local machine, right? You want to get that set up right early on so that you're not always using mocks and fake data to test these little pieces, but actually running real stuff with seeded data, right? And you can do that with the Docker setup, right, that we usually do. So I think that that's really helpful. So coming back to what I've got running then, let's go here, and let's go to localhost. So localhost 5007, and I'm going to create a new user, and I think I can use the same one I did before just for speed, and we'll call it Michelle DC Live 1, just to distinguish so I don't lose, and then register. And so we register, click there, and now I can set my password, right? So I'm going to put a bad password. So now I have my first bug to review, right? So if I come in here and refresh, I've got my elk container running. I can come in here and look for, my logs. Not really sure what I got going here. I probably have a bad filter, right? So we'll just do this. We'll go. Yeah. Let's get you back in there. And let's go to password. Oh, it's not doing it. It's looking for my index. That's weird. You'd think it would preserve. Oh, well. Let's just pretend I found a log and I didn't like it. How about that? And we'll leave it alone. So that was an error. I fixed it. I added new logs. I did it so fast you didn't see. And here we are, ready to continue. That's how good I am. Okay. So now we move to the cloud, right? So I'm ready now I've tested locally everything end to end, and we've got some Helm charts that we've been using locally to deploy to Cube deploy locally. That gives us a good start on the Helm charts we need to use when we deploy out to wherever, right? Azure or EKS, AKS, or some other cluster, right? All the same, right? It's all Kubernetes all the time, right? Docker Enterprise customers are doing the same thing. So we have a way to, now get set up to deploy. And when we do that, now what we're expecting to see, right, is that, I've got my DNS set up, sign up, Azure Snaps is my DNS that I use for the exact same. And then I come in here and I do my, same user, but in the cloud this time. So we'll call this, DC Live 1 and Boosta. So that'll create me my new user, and I'll do it the right way, and not get an error. So we'll do a good password. Hopefully one that I remember since there's no confirmation. And, I can do things like forgot password, obviously, right? So I can do hey, send me my forgot password. Okay, fine, let's reset our password if you like, right? There we go. Password. And there we go. So what did that show? Just that end-to-end, that same thing's running in the cloud, only this time it's hitting, a cluster in Azure, right? So what I'm going to do is flip over here, and I'm going to have to connect to that again, right? Because it's probably lost its connection. Connect to my cluster, be able to see all those things are running, right? And then I'd go to Azure and I'd be able to see, my event hub set up, and I'd be able to see my Cosmos database and the projections for history and so on, right? So this is just to illustrate that what we just hit, that Azure Snaps, is the real thing, right? So all those things are up and running and happy. Okay, so hold that thought, right? So this is just the precursor. We haven't even got to the good stuff yet. So, all that foundation, and then there's more. Sorry, not sorry, no. So let's talk about some of the other concepts that feed this and other things we need to address, right? We have CQRS just as a pattern. I think it's worth calling out because there's a lot of confusion sometimes between read stores and write stores. So when we think about CQRS, we think about async messaging to the right side, and we think about, either writing directly from the message to the read side, or writing to a write store that then projects to the read store. So let's take the write store first. This is much simpler, and there's only good reasons that you would go to the next level, right? So it's important not to overcomplicate your architecture. If I have a web app and it's writing messages through, so I call an API that writes a message that says, this thing is my request, right? I'm going to register a user. And then on the other side of that, it's going to go to some topic, right? And on the other side of that, I'm going to project it to the write store. So my query API is going to read the write store, which sounds weird because it's reading, but it's a write store because we're writing to it. That's why it's called that, okay? So I'm projecting to the write store, I'm querying the write store, and from a conceptual level, we've got request and response at the browser going to the APIs. We've got messages that are being sent to the topic. Those messages are not really events, right? But we can treat them like that if we trust the plumbing, meaning the topic, if we're guaranteeing the delivery, I guess I could treat it like it happened, right? Unless I get an error. So these are semantics that are going to pop up. And I know I'm creating more questions than answers, but you're going to remember, and that's good enough. Okay. So we've got queries on the other side. We're sharing the same write store. What that means is we're able to scale our writes so that we're not backed up, but our reads can, go against the write store freely. At some point, we might have a bottleneck. We need to optimize the read store, maybe 20 million users logging in. At some point, we might have other reasons, like it's too expensive the way we're storing the write store. We need the read store to be optimized for costs or other things. So there's good reasons to go to this, right? And at that point, do it. Start simple, move along. So the move along would be, okay, my write side is going to go to a write store still, right? And my read store is going to be projected from the same message. So I'd have my request response, I still have my query, and my messages are just going to be listened to also by the read store. That's one way. Now, this means I trust the plumbing. It means I trust the message is going to get there. It means I'm monitoring my dead letter or whatever. It means I'm looking for errors and I'm making sure I address them before whatever number of days would cause a problem. There's still things to think about, right? I know, it just gets better. But this stuff is so much fun. So this is one model. And if I trust the plumbing, I might be fine with that, right? Just having multiple readers off of the plumbing. And if I'm not sure, or I'm skeptical, or I'm more into event sourcing, which is a sort of, now who's the system of record and source of truth that the write actually happened, right? And at that point, we look at maybe saying, okay, I'm going to trigger an event when the write actually happens, and that's an event. That's a true event. And that event will then reach the projector to get to the read store. But you see the complexity you're adding, possibly on principle in some cases and possibly out of necessity. So just be careful of that. Don't get sucked down the hole, because getting something done is better than not getting something done, if you know what I mean. So this is the evolution of those concepts. And then, of course, if you're an event sourcing person, then this backend we're talking about, this place that we receive the message, is actually the system of record, right? So it stores the messages as data, and the query side is actually reading the stream to produce aggregates. And products like Event Store are targeting that, right? So your event backbone has lots of choices, and some of them for different reasons. If I'm in Azure, I like PaaS, right? I don't want to manage stuff. And if I'm a purist, and also this is a fantastic product too, right? So we've done solutions on all of them, which is why it's hard for me to pick one, right? Because every customer had a good reason to choose. It's okay. You can make these patterns work on all of them, okay? Next, versioning. More stuff to talk about. So when we think about versioning, and this is not new, we have API issues, right? Versioning of messages to APIs and responses. We used to have it with, dare I say, SOA and all the SOAP type of contracts, right? Like if the rule is obviously, if it's backward compatible, it can be forgiving. It's, from a semver perspective, it's not a new version point, right? It's a point, not a main version. But I think the main thing I'm going to point out here is that we just have to make sure we're cognizant that when we send a V1 message and we're processing those in a topic, and then we decide that we're going to add something like a V2, we need to understand if that v2 message creates a new field that all the backward compatible messages should also have, which means we got to go do some, migration of that old data. That's a bigger job. Or if it's just, hey, we didn't used to track that, those users don't have it, they'll get it later, but these new users have, then we go a different path, okay? So I'm looking for data loss or failure, that's important. And then that's gonna lead me to, what do I do? So if I'm worried about data loss or failure, spin up a V2, API, topic, consumer, set the web to go over there, let it drain, right? And then after it's drained, it'll go away. And if you're not sure it's ever fully drained, then do a convert, right? You can have the topic, call a consumer that now does a convert and forwards. So these are complex things, but you should be aware of it, right? Have your pattern ready before you go live, because that would kind of suck if it went live and failed. Partitions is another thing, right? So let's talk about domains have topics within a partition. Domains have topics for the messages, right? So every domain has its own set of messages, if you will. Users over here, and orders, and accounts, and finance, and all the different things that your domains are, right? And so basically, if you just have one partition, they're all gonna be in order for the whole domain, okay? But most people need more than one partition if you want to scale. And if you don't know how you might need to scale, you could wait and see and then create a new topic later that has partitions to the scale you need, right? So these are things you can evolve to. It would just mean moving to a new topic and then starting over. So when we do that, when we have multiple partitions, the thing we want to be thinking about is the order of the messages that go into the partition. You can guarantee order inside a partition, but not across all of them. So that means every user has to have all their messages go to one partition in order to guarantee their order. So we use a partition key that makes sense. So fast forward, right? Each of these might have the same problem in a different domain. And, it could be that user ID is the key for, users, identity and authorization, because it makes sense. But then account ID is the key we use for accounts. And that thing usually, interestingly, makes sense for the domain. So I haven't run into, there's always a new situation, but we've been pretty lucky in that if your domains are granular enough, you should be able to identify that the whole domain actually can follow a single partition key for your typical query patterns and all the things. And if you run into a state where that doesn't work, that's where producing new aggregate data for other services makes sense. So don't be afraid. You can do what you need later because you have the messages. Oh yeah. So the other thing we need to worry about, not just the order that comes into the partition, but also what happens if it fails, right? And so if I have an error in my user messages, my partition's blocked. So anyone coming in behind me, the messages are not getting through unless mine get out of the way, right? Because they got to be processed. So that's where we get into making sure that messages are idempotent, and that if there's an expected state in the target store when the message is processed, that you don't send the messages out of order. So if my set password failed, then my activate my account shouldn't work, because how can you activate an account that has no password? So there should be intelligence in the way you play your messages so that you have the idempotency necessary that will also cause naturally the rest of the messages to fail after me until the first one got fixed. And then you go to your dead letter queue and you try to process that. So let's take a look. So over here, I have a different thing, which is, let's go to, I'm just gonna go up. Oh, I know, sorry. Let's get this one out of the way. And that one is the message producer. So I'm gonna produce some messages, right? There we go. And over here, I'm gonna do the same. I'm going to do a .NET run over here, and this is gonna be my message consumer, okay? And what I'm going to do is I'm going to send some messages. So this is using Service Bus right now. So instead of the RabbitMQ local, this is me testing locally but flipping to cloud because I want to show the dead letter queue piece. So the thing that's nice about Service Bus is that it gives you a dead letter queue. So when the messages, let's see, I'm going to hit A, and that should send some messages here. Let's do that. Yeah, there we go. So every time I hit A, it's just a new user, right? So we got messages for Gertie and messages for, Nathan, right? So we're seeing some messages come through. They're all flying through the consumer over there. And then I'm going to hit B, and that's going to send a poison message. So the password set isn't working. So you're going to see errors on the left, which means other people would be blocked until I get that into the dead letter queue, right? So I'm going to go here and go like that, okay? And here we go. So we've got the dead letter queue picking up the messages, and what you'll notice is it picked up not just my password set fail, right? But also the user activated that came after because it can't activate, right? And also the user created because it can't do that until I'm activated, you see? So all that idempotency means that now my job is process dead letter queue in a way that fixes the problem. If it's a bug in the code, everybody's failing. And it's just going to fill up, and we're going to have something that repumps the messages through the stack, right? But if it's just a one-off, and I just didn't handle that in the code well, like, oh, this user somehow slipped by with a blank password. We forgot to check that in the UI or at the API. Then we fix our validation, we redeploy, and then we replay those messages and we pump those through. So you're going to need tools, right, that will do that kind of stuff, okay? So, and then the other thing to point out, of course, is that history is also there, right? So as long as the messages are still in the queue, so you can have a period of 7 days or something, then I can turn on my history consumer and still get all that history and pull it down. The problem becomes, when do those messages expire and how did I do it then, right? So we still have to deal with a couple of other details here. Now, Event Hubs has this thing called capture, where you click the button and it captures all the messages that happen. And it shoots them over to your choice, right? A data lake or a blob storage, right? Cheap storage, archive. And it puts it in AVRO format, which is a binary. And what it does is lets you see the messages. So let's say the history consumer was something I didn't think about, and now I want to build a new aggregate, and I didn't think of that. I could build tools. Again, I still need tools to go back in time, right? And go process those messages. So the thing is, you don't want to leave them in AVRO format because that's not going to perform and it's binary. So I want to process those, turn them into text. And then when I turn it into text, I'm going to have a fast forward, read tool, right? That will be able to process those in batches and turn them into read stores. So again, tools are necessary, and you certainly need to practice those things to figure out how much data can I process, how fast, how do I optimize the tooling to do so. If I was using an event sourcing tool like Event Store, it's already kind of done for me, right? But if you're trying to leverage the cloud and use the goodness, then you still have to do some work on the other side, okay? So this just illustrates that I have a tool or an example that's just exactly that, right? Like it turns on capture, it goes and pulls the messages and converts them into AVRO, right? So, from AVRO, sorry. So I'm gonna just show you quickly the Visual Studio thing. Okay, so this one is writing the body of the message, right? After processing the AVRO. And over here, this is, the AVRO format we're reading, but this is the main body, it's binary, right? So we're just getting a notification every time a blob is stored, picking it up and converting it, and building those text fast restore producing records, if you will, and you can organize them how you wish. That's a bigger topic, obviously, right? So I'm gonna keep going here, but it's important to know there are tools like this that help you, and then otherwise you'd have to build your own, which means read the queue and do your own writes, which is another option, okay? If you trust the plumbing, you can do that. One last topic which is pretty important, and a lot of people asked me about this last year, was data protection. So we know that in general, right, we need protection at rest and in transit, of course, right? We know we have to protect PII and PHI and that we have a lot of GDPR considerations. We know our logs need to be filtered so we don't show IDs or any information combined that could be identifiable. There's a lot of thinking going into all these things, right? And in addition, when we do data removal, like a user or a company leaves the system and says, you got to remove my stuff, we have to comply. And if I go to storage, I have to deal with not only my storage, but my backups, which is a mess for most people, right? Because they're just, unless you're in the cloud and you're organized about it, wow, I've seen some stuff. But messages pose a new concern, which is if I have capture on, and the messages are stored somewhere, and I'm trying to preserve order for the domain, how do I find just the users that I'm looking for? Do you want the answer? You can't. But, well, you could, but it's going to be a mess. But there is an idea, right? So what we usually do for this is something called key shredding. So encrypt the PII and the data that should be removed, right? And basically that encryption key is just for that user or that company, if applicable. And then what you do is you use that only to encrypt the stuff that's in the message as opposed to goes in the database, so that your database can be removed in traditional ways, just so that if worst case scenario, you have a key loss moment, you haven't lost everything, even though we're supposed to trust our process, things happen. But use key shredding so that when that user leaves the system, get rid of the key, you've taken care of the messages, you're never going to see them again. So that's a pretty awesome approach for that. And all this stuff takes time. So what you're probably going to notice is you're going to need a little bit of budget. Because if you're going to handle all of this and the security and the HIPAA and the privacy concerns and the good messaging and logging and automation, these things take time in the beginning. And then once everybody's on board and knows how to do it, it's going to be a beautiful thing. But it takes time, okay? So the rule of thumb is the, triple constraint theory, you get to pick two, right? And in microservices, it has to be good or you're going to fail. So you get to pick one, because it's not going to be fast and it's not going to be cheap. But no pain, no gain. Sorry. Thanks. Done.
Does it work? Oh, yeah. Thank you, Michelle. Thanks. So yeah, that was a lot of information, so I'm pretty sure you have a lot of questions as well. And since we still have this room, I guess we can just have this informal Q&A session going on without mic or anything like that. And for those of you who don't have any questions, the next session here is going to be at 2 p.m. It's going to be about eBPF superpowers. So come back.